Welcome friends, welcome to the lecture series of digital electronics. So today we are going to learn about the Quine method. So in this method, we are basically getting idea about Boolean simplification, that how a function can be simplified with this method. But that was also possible with the K-map also. So in order to K-map, how it is different, first we can understand by that the K-map was only, we can say that it was only for the particular variables of up to the 4 variables, not more than that. So that's why it is a limited method, right? But in this case, if you check, the method is for more number of variables, right? Or we can say tabular method also. Why? Because we are having a table for this method, right? Whenever we try to solve, or we can say simplify the equation. So first of all of you must remember this minterms and its representation in binary. Okay, it will be helpful for you whenever any kind of example will be given to you. So from this table we are getting these values for the minterms. If we can say that it is mentioned that the 0th minterm is there, third minterm is there, 7th minterm is there. So this minterms values are represented in binaries, right? So let's go to the first phase of our example. So this is our example. Here you can check that 0, 1, 3, 5, 7, 8, 9, 11 and 15. So these are my minterms given for the simplification. So I have written the 0 and 1, that is our binary representation of the particular minterms. So from that table we have written these variables. Now what we need to do, that first of all you can simply write these variables like this way. This is our variables. Now we need to group the variables, group the minterms, group the minterms, right? First I have checked for the term which is having no 0, right? No 1. No 1 is there, and that kind of value is only for the 0. See over here you can check all the zeros, no any single 1. So I have written that thing and I have mentioned that no ones, right? After that only single one. So if you check, there are two minterms from this particular mentioned over here, and we are checking from that only. We are just going to that slide to check the values of that particular minterms, right? So now I think all of you must remember, and all of you must write down that values from the table, okay, for this respective minterms. After that, check that how these values are differ, that 1 and 8 both having single ones. In that condition, we don't mind the places for that particular one. We are just taking the account of a single one only, right? After that, if you check, there are two ones, and we have grouped together that two ones together, that is the third minterm and ninth minterm, seventh minterm for the triple ones, and 11th minterm also having the three ones, and the 15 number minterm will be having 4 ones. So it will be only one single in that group. And now the main work will start, right? I hope that all of you must be clear up till this. We have just done a single job, that is our grouping technique, by having same number of ones, right? So in simple language, if we understand that we need to check the ones only, right? If two minterms having similar number of ones, then they are grouped together. Okay, so that's all for this step. After that, the second step. Now we need to we can say eliminate the particular terms. So if you can check, here is m0 term and here is m1 term. Now for the elimination technique, what we need to do, we need to eliminate the functions. Like first of all, we are eliminating this m0 minus m1. So if you check over here, m0 minus m1, so here you can check all the first three zeros are same for both the terms. Now this fourth term is changing. If you can refer this as in, this one is A row, this one is B's row, this one is C's row, and this one is D's row, right? So this variable, D variable, is changing over here. So what we will do, we will just put on only a negative sign onto the particular section, right? So on that section we are basically doing the change, that this mean term is getting changed, and we are putting only a dash over there. So here it will be dash, or we can say the underscroll, not zero. There is a mistake in this particular area, right? So mind one thing, that it will be dash over here like this way. Now for the second, now we need to repeat this for the whole group, right? See, if we have eliminated m0 from m1, then we also need to eliminate the m0 from m8, right? So both will be done together for the whole. So this way it can be eliminated. So here if you can check, m0 is eliminated with m8. Now first a variable is changing over here, 0 to 1. So we will put a dash on that particular position, and rest of the digits will be same. Same way we will also do this thing for m1 to m3. See over here, m1 to m3, from m1 to m9 also, right? So this way it can be done. But mind one thing, that whenever you are eliminating these terms, you must remember that we are just eliminating the terms which are having only single one change, right? If you can check over here, the only one digit is changing, not more than one digit is changing, right? If it is changing more than one digit, then it should not be eliminated. Okay, so kindly remember this thing and do it at your own of this all the min terms, right? So same way this procedure can be repeated up to the m11 to m15, and we have done the same thing, that we have put the dash marks, or we can say the underscroll marks, at the positions wherever the digit is getting changed. So after all, whenever we are having a thing, that is if you can check, the ink is all over the slide, so let's erase this. If you can check that this particular anyways, we will continue on this thing, that if you can check now, the min terms will be now like this way, that in the previous slide we have seen this thing, that this way it can be represented, right? So we have particularly mapped this thing, and we will keep on repeating this thing until we will get the terms wherever the no elimination can be possible, right? So this one is the particular term wherever the no min term is possible up till now. So this way it can be understood, and likewise if you can check over here, this all the possible conditions are added here. So all of you need to do that, whatever the a, B, C, D variables are there, we can check that 0, 0. So B bar, C bar. Here you can check B bar, D. Both the variables are same. If any variables are changing, then we are not taking that into the consideration, right? So that is the thing. And from here, C, D. So these terms are getting outside from this particular min terms. Now what we need to do, that after taking out this particular terms, that is of B bar, C bar, BD, B bar D, sorry, and CD, right? So in this condition, what we need to do, we need to repeat the procedure of grouping. So see, if we can group the quads, that means 4 times the ones, or we can say the 4 terms if they're possible, then quads of min terms in the adjacent groups to obtain groups of 8 min terms, right? There are no such matchings in this table particularly, whichever I have shown over here, but if it is possible, then we need to consider that thing. Now what we need to do, whenever we are doing this elimination technique, we just put on this right mark onto the places of that particular min terms. If we are doing over here, then we will put right check mark, check mark, check mark, right? So this way, so these are the prime implicants, and they will appear in simplified Boolean expression of particular y function, right? So here you can see there are no such terms in table, but there are 3 such terms in table. From that terms we have taken out, that is our B bar, C bar, B bar D and CD marked on that table. Now we are preparing this kind of table. Let's understand what is this table. So here we are representing the terms whichever I have taken out. So this all 3 terms, now it is represented in decimal numbers of corresponding to the prime implicants. What we will do, then this table will consist of the min terms contained in the given function of the pi, that is our prime implicant, and the decimal numbers of the min terms is written over here. As you check, this min terms decimal numbers are there. After that, what we are doing, we will put a cross mark in each row under the min terms contained in a particular prime implicant. See, 0 is there, then we will put a cross mark. 1 is there, then we will put a cross mark. So this cross mark will be there. After that, what we will do, then we need to find out the min terms that contain only one cross mark in its column and encircle this cross marks as shown in table. Here you can see, if we check, this is only one cross mark over here, so we will round it. Only one cross mark over here, we will round it. Only one cross mark over here, we will round it, and only one cross mark over here, so we will round it, right? So this way it can be done, and prime implicants can be deduced. So this way the output is only for the B bar, C bar, right? If you can check B bar, C bar, this min term is only having 0, that is our essential prime implicants B bar, C bar, and CD are called as the essential prime implicants. How? The encircled min terms 0 and 8 are contained in only one prime implicant. See, if you can check, 0 and 8 is only in this prime implicant, not repeating, right? So if you can check for 1, it is repeating. If you can check for 11, it is repeating. 9, it is repeating. 7, it is not repeating, right? So this way, and min terms 3 and 11 are contained in CD. 3 and 11 are contained in CDs. Whichever the min terms are not repeating will be considered for the essential. B bar, C bar plus CD will be the final answer for this example. So this way Quine-Cluskey method can be applied, and likewise we can easily find out, or we can say the easily eliminate the particular Boolean equation from this method. So this method is also called as the tabular method, and it is more oftenly used for the more number of variables, more than 4 variables, right? So that's all for this Quine-McCloskey method. If you gain some of the knowledge from this video, then you must like and share my video, and if you want to see more this kind of videos, then you should definitely subscribe to my channel.